talking about section 4 today, and we're going to talk about systems of equations in 3 variables. So until now, we've had systems of equations in 2 variables. And if we, looked here, right, at this lesson where you have a system of equations in 2 variables, you have 2 variables that you're solving for, right? X and Y. So you basically had 2 unknowns, X and Y. And that's why we needed 2 equations to solve them. In math, you always need the same number of equations as you have unknowns, okay? So always need same number of equations as unknowns. So if you have 2 unknowns, you need 2 equations. You can have more, it's extra information. If you have 3 unknowns, 3 variables, you need 3 equations. Otherwise, you can't solve them. Okay, you can't solve for them. Okay. Now, when we had 2 equations and 2 unknowns, X and Y, each of the equations represented a line, and the solution was the place where the lines intersected, right? If you have 3 variable equations, these represent planes because now you have 3 dimensions, X, Y, and Z, all right? And in the same way, the solution of the system is where the 3 planes this time intersect. And so you can see that, right? You can have planes that will intersect or planes that won't intersect. And in the same way as we saw with lines, you can have one solution, no solution, or an infinite number of solutions. So same exact thing as with the doubles, okay, with the 2's. So how does it look if there is one solution? If you have one solution, take a look at these 3 planes here. They all intersect at that point in the center. So that's one solution. Now, if you look around the room here, right, look at this wall. And look at that green wall over there. Those are 2 planes. And look at the ceiling. That's a 3rd plane. All 3 of these planes, all 3 intersect each other at that one point in the corner, right? You can have, 2 of them intersecting in other places, but all 3 intersect at that one point. Okay, so that's one solution. Another situation where you get infinitely many solutions is if you have a setup like this, right? You see how these are all kind of like going into each other? And all 3 planes intersect along this line here, right? Right there. And so here you have infinitely many solutions. And all of the points along that line where they intersect are the solutions, okay? Or you can have, just like we had the lines that are drawn on top of each other, you can have all 3 planes lying on top of each other. So again, you've got an infinite number of solutions there. Remember that plane stretches in all directions. So how do you get no solution? The 3rd one is the most obvious case. None of them meet. So for example, the ceiling, the floor, and then, like the floor of the story underneath us, right? Those don't intersect, no solution. You can have one like this. So look, the yellow intersects with the other 2, but not all 3 intersect at the same time. Or like the first one, okay? All right, so how do we solve a system with 3 variables? You basically reduce it to a 2-variable system. So you eliminate one variable. And the way you do that is you have to use 2 different pairs of equations. And then you have to solve the system, okay? So solve the system as before, substitute, blah, blah, blah. Okay, take a look here. The most important thing here when you're working with these is to be as organized as possible, right? So we're going to label each of these 1, 2, we're going to number them. We're going to label them 1, 2, 3. So let's call this one equation 1, 2, 3, and they're forever going to have those names, 1, 2, 3. Now, you have to eliminate one of the variables. It's up to you which variable you want to eliminate. Basically, what I do is I look and I see which one is easier to eliminate, right? If there is a variable with a coefficient of 1 or minus 1, I like to start with that one. So for example, look at the z. It's got a coefficient of minus 1. It's easiest to get rid of that one, okay? So we're going to eliminate z. Now, to do that, you want to use equation 3 with any one of the other two, okay? So why don't we use equation 3 with equation 2, okay?
Is there always going to be like a coefficient of 1?
Yes and no. No, not always, but you know, it's okay.
For now.
Yeah, for now. Okay, so let's do 2 and 3, right? If I have equation 2 and 3 and I want to get rid of the z, if this is a plus 2, I want to make this a minus 2, so I need to multiply everything by 2, okay? So here's what I do. I write down equation 2. And then equation 3, I'm going to multiply it by 2. So I say 2 times equation 3. Okay? So I get negative 10x plus 9y.
Wouldn't it be 6y?
Oh, 2, sorry. Yeah. Plus 6y. And then minus 2z. Equals how much? Negative 34. Okay, students always forget to multiply that constant, the poor old constant. Okay, 1 sec. So we're multiplying by 2. So negative 10, positive 6, minus 2, negative 34. Okay, now we're going to add these. When I add these, I get negative 13x plus, how much is that? 11y equals how much?
Negative 16.
34. Oh, no, never mind.
Okay. Okay, now I'm going to do this again with a different pair. Okay, so how about, okay, I used 2 and 3. How about we do 1 and 3 this time? Okay, so I'm going to have 1 and I'm going to have 3. So this time, equation 1 is 2x plus 4y minus 5z equal to 18. What am I going to multiply 3 with?
Negative 5. Wouldn't it be negative because you want to get it to be positive?
Right, we're going to multiply by negative 5. So I'm going to get 25x minus 15y plus 5z equal to, what's 5 times 17 these days? 85? Sounds good. Positive. So this goes away. So what do I have? 27x minus 11y equal to 103. Okay. Now I'm going to use this and this. There you go. I'm going to use this and this. 2 equations, xy, xy. So now it's like one of the problems from section 1 or 2, right? So let's use this and this. I have negative 13x plus 11y equals negative 61. 27x minus 11y equals 103. And look at that. Like, it's a perfect setup. You can totally eliminate the 11y's. Add them up. So I get 14x is equal to how much? 42. Look, it even divides evenly. X is 3. And so now we're going to do back substitution. So first we're going to find y. For that, we're going to plug 3 into one of the, equations that we just used. So let's just do, I don't know, this one, negative 13x plus 11y equals negative 61. So negative 13 times 3. So 11y is equal to negative 61 plus 39, so it's negative 22. Y is negative 2. How do I find x?
You mean Z?
Oh, z. How do I find z? Plug it into to one of the ones in the beginning, right? Any one of them will work, right? Let's do the number 3. Okay, let's do it just because the z is alone there. So negative 5 times 3 plus 3 times negative 2 minus z is equal to negative 17. So negative 15 minus 6 minus z equals negative 17. Minus z is 4. Z is negative 4. Now, how do we give the answer? How did we give the answer in the the system of 2 equations? As a what? As a coordinate point. Here too, we have to give it as a coordinate point, but it's got to be 3 coordinates, x, y, z, right? So x, y, z, it's going to be 3, negative 2, negative 4. Okay, and this is a point, right, in 3-dimensional space. So 3, negative 2, negative 4, right? It tells you exactly where that point is in space. Isn't that cool? Right? Like, that's so cool. Like, you literally found a point in empty space in 3D. You guys should be more excited about this than you are. I don't know what's going on here. Okay, thank you. There we go. All right. So let's do another one. Let's label these 1, 2, 3. What do you think we should eliminate? X. X is easier because it's alone. Yeah. Yeah. I mean, yeah, because since the x has a coefficient of 1 or minus 1, it's easier to work with that one. Okay. So why don't we use equations 1 and 2? So 1 and 2. 1 we're going to leave as is. What are we going to multiply 2 with? 4. So we're going to get negative 4x, 20y, 16z is 4 times 48, 192. Add them. These go away. 17y, 22z is, what is that, 210? Why not? Okay. Now, we used 1 and 2. We can't do 1 and 2 again. So you can do 2 and 3. By the way, you can also do 1 and 3. Like, there is no law that says you can. It's just a little bit more complicated because to eliminate x, if you use 1 and 3, then you would have to multiply by like 6 and negative 4. You see what I mean? Instead of just multiplying one of them. Yeah, so work smart, not hard, right? Yeah.
Is it like the same thing when the coefficient isn't a 1, when it's like set like 4 or 5?
Yeah, exactly. You're just going to multiply both of them. Yeah. So 2 and 3, so that's 3. And then 2 we're going to multiply by 6, right? So we're going to get negative 6x, 30y, 24z. 6 times 48 is 288. That's why we work these out before class. 288. Okay. 28y. And you know what? Yeah, the numbers get big. It's okay. Have faith in the math. Okay? 28y plus 29z is 288. Okay. So now let's write those down here. Okay, so we're going to do a little bit of work here, but it's okay. Okay, so let's get rid of the y's. It seems like the lesser of the two evils, right? So what are we going to multiply the first one by? 28, right? And this one by negative 17. I know.
Could you do negative 28 and 17?
Sure.
We're going to have our calculator for this.
Okay, so if you have this on the non-calculator part, the numbers will not be as big. Or if the numbers are big, it'll be on the calculator part. You know what I mean? So like, right? It depends. Yeah, yeah. Okay, let's do this. So here, we're going to have 476y, 616z equals 28 times 210. Anybody?
28 times 210 is
5,880.
For which one?
28 times 210. That's what I have here. So negative 476y minus 493z negative 4896 goes away. Here I have 123z is 984, and wouldn't you know it? That's 8. Okay? So to find y, we're going to plug it into one of the ones before. Why don't we do the first one there? So 17y plus 22 times 8 is 210. Okay, so 22 times 8. 20 times 8 is 160. Then another 16, 176. 17y is 34. Y is 2. You guys need some time to catch up. Okay. The y's? Okay. And then I'm going to use equation 2 to find the x, because why not? So negative x plus 5 times 2 plus 4 times 8 is 48. So negative x plus 10 plus 32, 48. Yeah, they are. So x is 6, right? Minus 6. Okay, so the coordinate, yeah.
The only question is, why did you multiply those by -17?
So I wanted to eliminate the y. To eliminate a variable, you need them to have the same coefficient but opposite. Okay, so the coordinate point is negative 6, 2, 8. It's got to be just like that. You've got to have the parentheses around the coordinate points because that's how the notation works. And we are sophisticated math students, so that's how we do it. Okay, questions? The x? Okay, let's do the x. Okay, 1 and 2 it is. 1, 2, 3. Let's get rid of the x. So 1 stays as is. What are we going to multiply 2 by? Negative 2, so I'm going to get negative 2x minus 4y plus 16z. No, 8z. That, you know, Aaron, maybe I should have had that cup of coffee. Yeah. So negative 2, negative 14. This goes away. Negative 3y plus 5z, negative 9. Yes? Okay. Now which ones do you guys want to use? 2 and 3. I heard 2 and 3 first. Let's do 2 and 3. It's easier actually. Okay, so we'll see. So 6 times 1, right? Yes? No, negative 6 times 1. Negative 6x minus 12y plus 24z equals negative 42. And then we said 3. 6x, 3y, negative 9z is 15. So we get negative 9y plus what? 15z equals how much? Negative 27? Is that it?
Is this, yeah. Oh, yeah.
Wait, why'd you multiply 1 by negative 6 to get? If you multiply.
Sorry, this was 2 and 3. I'm sorry, 2 and 3. Okay?
Wait, can you move it?
Okay. Yeah. So what do you notice about these two now? Let's put them here.
Multiply -3.
Yeah. They're gonna cancel out. They're gonna be the same, aren't they? So if I multiply this one by 3, I'm gonna get negative 9y plus 15z equals negative 27. Negative 9y plus 15z equals negative 27. And then when you add or subtract them, you get 0 over 0. Yeah, so multiply by negative 3, these will become, the negatives. So you get 0 over 0, 0 equals 0, which means it's what?
Infinitely many solutions.
Infinitely many solutions. Now look, I kind of went along with what you guys said. I was, asking you, but if we had chosen 1 and 3 from the beginning instead of, 2 and 3 or 1 and 2, it automatically would have been 0 over 0 at that step, right? But it's okay because you see that it can happen at any step. And then as soon as you get 0 over 0, you know that that's infinitely many solutions. Yeah.
If it's not 0, 0, can you do 1 and 3?
Yeah. I mean, if you do 1 and 3, yeah, you can do any combination and it works out fine. Harrison.
There's a question on the next.
Okay, hang on. Yeah.
I was gonna ask about the next one.
Oh, the next one as well. Okay. All right. So what is your question, Harrison, about the next one?
I was gonna say, I think it's the same thing.
Yeah.
Just because.
Okay, let's see. Let's see. So why don't we look at 1 and 2? So we can multiply 1 by negative 2, right? And we get negative 6x plus 2y plus 4z equal to negative 8, yes? And then 2, we have 6x minus 2y minus 4z equal to 11. When we add these, I get 0 equal to what on the other side? 3. And since 0 is not equal to 3, I get no solution. So it's very, very true that you can tell from the very beginning, right? So how could we tell from the very beginning? By looking at 1 and 2.
You know by the first, by like the first number.
Mm-hmm. Right?
You see if they multiply into each other.
Yeah, so look, do you see how number 2, the coefficients of x, y, and z are double the coefficients of this. So, okay, double, double, double. If this was also double, it would have been 0 over 0, infinitely many solutions. But since these are all double, 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 they'll go away, but this will not go away. You're going to have 0 equal to a number, which is,
Would 11 have to be 8 for it to be?
right. But look at this one before I take questions. So look at 1 and 3, right? The coefficients, right? 3 times, 3 times, 3 times, 3 times. All 4 of those numbers, right, are the same factor, higher. So you know it's going to be 0 over 0. Yeah.
But if you look at D, the first and the third,
Mm.
if you do the same A to C, you get infinitely many.
Yeah, so that's what.
Right. But the no solution kind of is more effective.
But if you
You know what I mean?
start at 0
So that's why you have to do that
Well,
one.
you